right, what's up, Joel? I hope you're doing well. Today is Thursday. I hope you are enjoying this fast-paced method. If we want to continue this, you need to make sure that you are completing all the activities completely and fully, showing complete understanding. I want to talk to you about that check for understanding last week, or that you did on Tuesday, because you missed a few concepts that I want to talk to you about on that check for understanding quiz that you took on the computer. That's one of the biggest reasons why I want to make sure that you're doing and completing all activities. You're watching all videos I'm sending out. My videos are my lectures. My videos are my presentations that I would give in front of the class. So you need to make sure that you're watching them completely and fully, so you're getting all concepts. You're not missing key little details. That is what had you miss a bunch of problems on Tuesday. So if you would have watched that video, you wouldn't have missed them. So you need to make sure you're doing this work if you want to continue this fast pace, okay? I'm enjoying it, and I think you are too, but we need to make sure we're doing the work, okay? Completely and fully. But today you're going to be learning about midpoint and segment bisectors, okay? So midpoint and segment bisector, they're one and the same, but they're different definitions. Midpoint is of a segment is the point that divides the segment into two congruent segments. So what that means is that, let's say from A to M it was 2, M to B would also be 2. They're the exact same, okay? It's just cutting it right in half. They're congruent, okay? And so segment bisector is very similar, except that a segment bisector is a point, ray, line segment, or plane that intersects the segment at its midpoint. Okay, and again, you already know what midpoint is because I just gave you that definition. A midpoint or a segment bisector bisects a segment. Okay, so what that means is that a line segment AB is getting bisected by line DC. You also have a point M that's bisecting line segment AB. Okay, so that's kind of what it means there. So let's kind of go into our activity and show you what I mean by this. Problem number 1 is review for what you did yesterday, or should have done yesterday. You may have done it today. Just know that if AB is 8 and BC is 15, you're going to add those together to get the distance from A to C, okay? But down here, we're kind of looking at that bisecting, that segment bisector idea. So point M is bisecting line LN. And we know this to be true because we have these two lines right here. Let me kind of draw a circle around it so you can see it better. That line right here and these two lines right here are showing us that line segment LM is exactly congruent to line segment MN, okay? I'm hoping you're getting that, okay? And so what this question is asking us is saying is that if line segment LM is 6, what that means is that if we were trying to find the total amount for line LN, we would say, okay, well, I know that this is going to be the exact same over here. And so what that means is that we can say that, oh, this is also going to be 6. Now, obviously, this is a pretty easy problem. They're going to get harder from here, so make sure you understand this concept. All we do from here, Joel, is we just add these together. 6 plus 6 is going to equal 12. And so that means our answer for here would be LN equals 12, and you have your answer right there. Okay, this is what I mean when it can kind of get a little bit more difficult, but this is practicing more of what you did yesterday, right? So this isn't point S is not bisecting line segment RT, because, well, you can kind of see that it's not centered, but also you don't have those two lines or one line that shows it's bisecting, okay? We can kind of go down farther. J is the midpoint, so now that you know the definition of J, you know that this is bisecting line segment HK. And so what we can do for this is we can go like this: 2x minus 1 plus 17 is going to equal the total distance of HK. Do you see how we're kind of not getting something equal to each other? So what you do instead is you go like this: 2x minus 1 equals 17. Okay, they're the exact same. We know that line segment HJ is going to equal line segment JK. Okay, so you add those together and you can slowly do our process of linear equations. Add 1 on both sides, you have 18. Divide by 2, x is going to equal 9, and that's your answer. Kind of keep going. That one's the same. That one's similar. That one's similar. That one's similar. Keep going. This is the exact same idea, but now you have a line or array that's bisecting it. I'm running out of time. If you have any questions, let me know.